In a groundbreaking announcement that could redefine humanity's place in the cosmos, NASA has reported the detection of what appears to be the first extraterrestrial signals originating from the direction of Proxima B. This exoplanet, the closest known to Earth, lies just over 4 light-years away and resides within the habitable zone of its parent star, Proxima Centauri. The discovery has ignited a wave of global excitement and curiosity. Could this finally be the moment when we learn that we are not alone in the universe? The path to this monumental finding began with meticulous observations made by NASA's advanced telescopes, which have been scanning distant stars and planets for any sign of life. Proxima B has long been a prime candidate in the search for extraterrestrial intelligence due to its Earth-like properties and relative proximity to our solar system. The signal detected is unlike anything previously observed by astronomers, marking a potential turning point in human history. The implications of this discovery are profound. Firstly, it offers compelling support for the long-held scientific hypothesis that life could emerge on other planets under Earth-like conditions. Secondly, and perhaps more intriguingly, it raises questions about the nature of potential civilizations that might reside there. Are they simple microorganisms or advanced beings capable of interstellar communication and travel? This signal from Proxima B does not resemble random cosmic noise or a natural astrophysical event. Instead, it exhibits a structured, repetitive pattern that suggests an intelligent origin. NASA scientists, working alongside international teams, are now focused on deciphering this message, trying to interpret its contents and understand the intentions behind it. The global scientific community is abuzz with theories. Is it a greeting, a guide, a warning, or something entirely unimaginable? This discovery has also stirred interest beyond scientific circles. Social media, government institutions, and dinner tables around the world are alive with discussions. People are now gazing up at the stars with renewed wonder, contemplating the possibility of distant beings doing the same from their world. What is their society like? How advanced is their technology and culture? These questions seem as vast as the universe itself. Moreover, the detection raises numerous ethical and existential dilemmas. If the signals do indeed come from intelligent beings, how should humanity respond? What protocols should guide interstellar diplomacy? Most importantly, how would such a discovery reshape our understanding of religion, life, and our identity? As a species, while excitement grows, caution tempers the response. NASA and other space agencies are rigorously validating the findings to ensure that the signal is not a false positive or a misinterpretation. We may be on the cusp of the most significant discovery in human history, and every next step must be taken with the utmost care and scientific precision. The world watches, waiting for deeper analysis and clearer understanding. The original signal that sparked this wave of speculation was detected in April 2019. It came from the Proxima Centauri region located 437 light-years away. Despite this distance, it is the closest star system to the Sun and 3 times farther than the third brightest stars in our night sky. The signal is associated with a triple star system, Alpha Centauri A and B, binary stars, and Alpha Centauri C, more commonly known as Proxima Centauri. Alpha Centauri A and B are quite similar to our Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is dimmer with an orange hue. Our Sun lies between them in size and brightness. The origins of this signal are linked to the Breakthrough Listen initiative, a project committed to searching for extraterrestrial communications. The signal was named Breakthrough Listen Candidate 1, BLC-1. With a $100 million budget, the initiative uses state-of-the-art telescopes across the globe. BLC-1 was detected by the Parkes Radio Telescope in New South Wales, Australia, while it was observing the Proxima Centauri region. Despite the enormous amount of data collected over thousands of hours, the scientists were able to spot this anomaly like a needle in a haystack. For a signal to be considered potentially artificial, it must meet 2 criteria. It should be limited to a narrow frequency range, which cannot occur naturally in space, and its frequency should fluctuate in a way consistent with the relative motion of the exoplanet and Earth. Scientists analyzed nearly 4 million signals collected by the Parkes telescope. After thorough filtering, they identified 5,000 distinct signals, one of which stood out. This signal had no known Earth-based explanation. It appeared only when the telescope pointed toward Proxima Centauri and lasted for a continuous 30-hour observation period. Further investigation revealed that the signal may be linked to Proxima B, an exoplanet discovered in 2016 using the radial velocity method. This technique detects slight movements in a star's position caused by the gravitational pull of orbiting planets. These variations are observed through shifts in the star's light spectrum, toward blue as it approaches, and toward red as it moves away. Regular repeated shifts typically suggest the presence of an orbiting planet. Proxima B is strikingly similar to Earth in several ways. It has a radius approximately 1.1 times that of Earth and a mass 1.3 times greater, suggesting it is a rocky planet with comparable density. However, there are key differences. Most notably, Proxima B orbits much closer to its host star, only 0.05 astronomical units away compared to Mercury's 0.39 AU distance from the Sun. While this would typically suggest extreme heat, Proxima Centauri is a dim red dwarf, meaning Proxima B receives only about 60% of the energy Earth receives. This places it squarely in the star's habitable zone, where conditions might support liquid water and potentially life. Beyond Proxima B there is an astonishing diversity of planets in our universe. So far, scientists have discovered over 4,135 exoplanets. On March 21st of this year alone, NASA added 65 new ones to its exoplanet archive, bringing the total count past 5,000. This marks a significant milestone in our exploration of other worlds. James Webb Space Telescope, JWST, the most powerful telescope ever built, 100 times more advanced than its predecessor, promises to revolutionize our understanding of these distant planets. With it, we can explore a wide range of planetary types, from small rocky bodies to gas giants larger than Jupiter, including those in potentially habitable zones. One standout discovery is Kepler 1649c, considered the most Earth-like planet found so far. Among thousands of candidates, about 55 have Earth-like characteristics, although most have not yet been studied in detail. WST's primary mission in its first year of operations includes the search for extraterrestrial worlds beyond our solar system, particularly those that might contain water and biological life. Its powerful infrared instruments allow scientists to peer into dense cosmic dust clouds, detect thermal emissions from young stars and planets, and identify crucial chemical markers such as water and organic compounds. Infrared light, particularly in the mid-infrared range, is essential for this work. It can penetrate clouds up to 20 times denser than visible light, making it ideal for observing the hidden early stages of star and planet formation. Both young stars and massive planets emit more in the infrared spectrum, providing valuable clues about their formation and evolution. JWST's MIRI instrument in particular is capable of detecting hot molecular gas near young stars, evidence of rocky planet formation and potentially habitable environments. Not surprisingly, much of JWST's early science efforts focus on understanding how planetary systems generate the building blocks of life. Its findings could eventually link the origins of our own solar system to those of other stars, and perhaps even answer the ultimate question: are we alone?